walls, the load-bearing walls, the windows, framing, glazing, and whatnot. And an additional 10% comes from the rest of the finishes in the interiors and the interior partition. So all in all, architecture industry has the opportunity to influence close to 50% of the global CO2 emissions. And this is not a small thing. It's a great responsibility and great opportunity. And if you combine that with the fact that by 2060, we will be doubling the current building stock. So between now and 2060, we're going to add one New York City to the planet Earth every 34 days, which is huge. So if you don't apply these climate responsive principles, it would be a big wasted opportunity, and the damage to the environment might be irreversible. So Japan, which is regularly subject to earthquakes and extreme weather events and wars and whatnot, has already used architecture as a powerful force for healing and reinventing the urban landscapes and building a better tomorrow. So there's something we can learn from what Japan is already doing. And again, architecture is important, but it's one of the things among many things. Like design goes along with policy and culture. So any change has to address these three issues. And within design, there is efficiency, there's resilience, and there's this new term called decarbonization. So eliminating the role of greenhouse gases completely from the built environment. And we have to do a few things in the short term, and we have to do a few things in the long term, so to address resilience, but also build a long-term strategy to avoid the emission impacts. So to sum it all up, in terms of the problem definition, if you take these three parameters, human activity, climate change, and the built environment, all three are related to each other. And the way we live today and practice architecture in general, this relationship is mostly broken, if not completely. And the good news is we can do something to fix it, and architecture has a big role to play in fixing it. And like we discussed, we're thinking of 5-minute breaks between different topics, so people can choose to ask questions. Kim, I don't know if there's already been questions or if people are typing anything in the chat.
Nothing as of now.
Okay.
So yeah, anyone, if you have any questions, you can keep typing the questions in the chat box.
And while people are typing, this image I put in here for the break, it's the Borneo rainforest in Asia. They're spread across multiple countries, but it's one of the biggest ecosystems on planet Earth, and also habitat to a lot of species, including orangutans. And what this picture is showing is removal of trees through burning for palm oil plantations. So all the palm oil that we buy also has an environmental impact. Forests are being torn down to plant these palm oil trees. Hema, let me know if we should wait for any questions or if we can move on.
I don't think there are any questions coming in right now, so I think we can move on.
All right. Okay, so from problem definition, we have moved on into the role of energy now. And let's first understand what climate change will do to building energy supply. And then we can talk about how buildings can respond to this climate change impact. So as we talked about earlier, if the weather is going to be hotter, and if there'll be more frequent heat waves, you will need more energy to keep buildings comfortable through air conditioning. And if not for all, at least for a certain section of the population, energy bills will become very unaffordable because higher demand leads to increase in prices. And because of the extreme weather events, there'll be interruption to continuous energy or electricity supply to buildings. And these are the impacts buildings energy supply can expect from a changing climate. So how can buildings respond? And whether the climate is changing or not, I think intelligent use of resources sort of prescribes these 3 steps in the following order. First, you maximize passive strategies, as Mr. Vice Chancellor has already alluded to. You focus on the orientation, the passive solar aspect, and how the sun comes in or how the sun is blocked, how you use daylighting and natural ventilation. And once you've exhausted all the passive strategies, you kind of employ energy efficient technologies to treat the building in terms of insulating the building envelope, or using all LED lighting in the building, or using high efficiency heat pumps, or even ground source heat pumps. So after passive strategies, it's energy efficient technologies, and whatever the load remains after the 2, you can meet with on-site photovoltaics or solar hot water, and off-site renewable energy. And if you can't meet all of the remainder of the requirements through renewable energy, you can do whatever you can to reduce the fossil fuel consumption of the buildings. And there is a mention of off-site renewable energy here, because if you take dense urban settings, buildings may not have the site area or the roof area to put solar panels on them. So while the building's energy consumption might be high, the ability to generate its own energy is not so good in dense urban settings, and buildings might be shadowed by neighboring buildings. So you can always get your energy from off-site renewable sources, and there are ways of doing it which would probably take a session on its own, but it's becoming increasingly important. And this trend has started more recently, and it applies to Western countries more than India. But increasingly, this talk of all electric buildings, because if you have combustion in the buildings, you have emissions. And you cannot completely avoid combustion, but you can mostly convert buildings to all electric. And so once a building becomes all electric, then it's easy to supply its electricity from on-site renewable energy, or let's say the utility plant converts to entirely solar and battery based, then all the emissions from your buildings are eliminated. And I know, especially in India, there's a lot of dependence on cooking on natural gas, or compressed natural gas for cooking, and certain other fuel types. But this is the new trend. So beyond all electric buildings, I would like to draw on this resource to look at different strategies for how buildings can respond to a changing climate. And this book is called Project Drawdown, and it's written by an environmentalist named Paul Hawken. And what he has done is he thinks we are already experiencing climate change, and things like fighting climate change, combating climate change, or what else? Or they're not the right terms to use or right approaches to use, because it's already here. So he calls for a drawdown, which is a complete scaling down of how we do things to bring the climate back in order. And let's look at what kind of strategies he advocates in terms of building energy. And please, again, apply this information to your own context. It may or may not be suitable to all places in the world. But net zero buildings is one of the strategies. What net zero buildings mean is they, on an annual basis, they produce as much energy as they consume at the very least. So net zero energy may or may not necessarily mean net zero carbon. So there's subtleties in there. Please study the differences. And the next thing I'd like to focus on is alternative refrigerants. Most of the refrigerants used in air conditioning these days are fluorinated refrigerants, which is HCFC, HFC. They are, all of them are potent greenhouse gases, and they tend to leak from air conditioning systems and refrigerators. So there are two aspects to the whole refrigerant issue. One, reduce the leakage, and two, use non-fluorinated refrigerants so that even whatever leakage happens, it does not impact the climate too bad. District heating, this concept has existed for a long time, especially on university and college campuses, where there's a centralized plant that produces heating and cooling or chilled water and hot water or steam for all the buildings on the campus. And it's much more efficient in terms of energy usage compared to each building having its own HVAC system. So, but it does not have to be limited to university campuses. Even housing complexes or any community-based situations can utilize district heating or cooling. Dynamic glass, it's an emerging technology, and but it has come a long way. Basically, there's thermochromic glazing and electrochromic glazing, which tint automatically based on how the sun is falling on it or how the temperature outside is. So let's say it's very cloudy outside, and they become very clear to let all the daylight in. But when it's really sunny outside, they tint a lot to block all the harsh glare and the solar gain from the buildings. It's a very useful technology. High efficiency heat pumps. Heat pumps generally are efficient in heating and cooling buildings. But lately they have become even more efficient, and you can also create hot water in buildings using heat pumps these days. But bottom line, the amount of cooling or heating energy they output is about 4 or 5 times more than the energy they take in to function. So, and smart thermostats, a lot of people in the audience might already have these technologies at home. But basically, what it allows you to do is not heat or cool the buildings at the same rate throughout the day. You can program things, and they're smart. They learn over time on when people are around in the buildings, when you don't have to cool or heat to the maximum extent and waste energy. Low flow fixtures, they save water, but the way they save energy is if your dishwasher or if your showers are using hot water, then the fact that you're using a low flow fixture means you're using lesser energy while using less hot water. So taking an example from a recent project, summing up all that we've discussed so far. Let's say there is a building and it loses power. So how do you maintain comfort and keep the building functional from an energy standpoint during the loss of power? It could be a combination of on-site photovoltaics or solar with an emergency generator that can kick in if the solar energy is not enough. But ultimately, they feed into a battery, and they're supplying energy to a building which is using daylight to dim all the electrical lighting, and it's running on ceiling fans and to decrease the requirement for air conditioning. So this is one example of how you can create a resilient building using available technologies and strategies. And I would like to break here before moving on from energy to water to see if there are any questions. Hema, can you hear me?
Yeah, Ramana.
Yes.
I have a question actually. Like the way the whole presentation has been till now, like you have touched upon so many points about agricultural intervention. So, like, do you have a, what do you say, a stepwise what they say, blueprint of actually making the whole any building to go through, like this is the method how you should actually check the whole building, like a strategy, something like that?
Yeah, so if you, Mr. Sunil Kumar, thank you for the
Yeah.
question. If you see at the top of the slide, the end section is summing up. So I will use one case study to illustrate how the project has employed all these strategies and where it is. So hopefully that will meet your expectations at the end. But I'll be happy to answer any questions after that. Did I answer your question?
Yeah.
Okay, great.
There's another question by Mr. Bharat M. So he's asking, can these electric buildings be retrofitted to old or heritage buildings?
It depends on what the situation is. If the building already has natural gas furnaces or natural gas hot water heating systems, then if you're replacing them, there is a good. If you're replacing those systems, there's an opportunity to replace the combustion-based systems to electric systems. But if you're not replacing them, and if they're in a good condition, it's worth taking a look at how appropriate it might be.
Okay. So another question by Ms. Shobha. She is asking if you can provide some details for orientation in Indian climate.
Mm-hmm. That's a good question and worth shedding some light on. But because the topic is introduction to climate change and adaptive architecture, I focused on the big picture. But maybe the example I discuss at the end might touch on the orientation aspect. And again, it may not be directly relevant to India, but please see if you can interpret on how it can be useful in India.
Okay. So I think there are no more questions. We can continue with the next session.
Okay. Before moving on to role of water, I want to explain what this slide actually means. Basically, this is a processing facility that in Texas that utilizes natural gas. And whatever excess natural gas there is, it's supposed to burn it and release it. So when natural gas, which is mostly methane, is combusted, it leads to carbon dioxide, whose global warming potential is 1. So CO2's global warming potential is 1. But when methane directly leaks before it gets combusted, its global warming potential is 20 or 21. So it's 20 times more powerful when natural gas leaks compared to what happens when it's burned. So a lot of people consider natural gas a bridge fuel before we completely switch to renewables because of its low global warming potential after combustion. But what this picture is showing is they've taken a picture of the facility using a regular camera and another camera that can detect natural gas leaks. So a chimney, which looks normal in a regular photograph here, actually shows that a lot of natural gas is leaking from this facility into the atmosphere. And just like refrigerants we talked about, it's important to avoid the leakage of natural gas into the atmosphere. Still no more questions, right, Hema? I can move on to water.
Yes, you can move on.
All right. So what will climate change do to the site and water situation of buildings? So, I mean, it causes loss of ecosystems and habitats for non-human species because of the extreme weather not being conducive to big forests maybe, or man-made deforestation. And because of sea level rise and increased extreme weather events, there's a greater risk of flooding to buildings and sites. And all these events can actually cause disruption of potable water supply to buildings, which our buildings depend on for drinking and a plethora of other end uses. So how can buildings respond to this possibility? basically you design, I think Professor Mohan will touch on this tomorrow in greater detail, but in a nutshell, the idea is to design the landscaping around the building, just like you would do in a pre-development situation. Bring it back to the natural situation as much as you can, so that you're creating new ecosystems or restoring old ecosystems and creating habitats for non-human life forms. And talking about flooding, there are emerging ways of dealing with flooding, especially for buildings that are in high risk flooding areas. One is wet flood proofing, which is, as you can see in the picture, you're deliberately creating a non-living space at the highest risk area at the bottom, and you're designing it in such a way that flood waters can pass through the building and not affect it negatively. Whereas this is wet flood proofing, but dry flood proofing, what it does is it completely sheds water. It does not let water enter the site, risky areas of the site or risky areas of the buildings through waterproofing or other design strategies. And water efficient landscaping, if you design your landscaping around the building with native or adapted vegetation, there is some water requirement while during the formation period, but after that they can purely survive on the rainfall in the region. And water efficient plumbing fixtures, in the US they're called WaterSense labeled fixtures, and increasingly they're consuming less and less water. Still, they need water to operate, a lot of them, if not all, but they've become very efficient. And gray water and black water recycling is increasing in prominence, especially as water becomes a scarce resource. Gray water is the water that comes out of your kitchen sinks or the bathroom sinks and your bathtubs, whereas the black water is what comes out of your toilets. So both can be recycled on-site or off-site and reused in a way that is safe and healthy. And in the picture is a facility called Water Hub at Emory University locally in Atlanta in the US. And what it does, it's purely based on plants, species, and natural filtration systems. What it does is it takes water at a campus level. It's serving the entire campus. Again, speaking of district systems or centralized systems. It's drawing water from the sewer system and passing it through the natural filtration and the treatment system. And the clean water that comes out at the other end can be used to flush toilets or irrigate the landscape on the campus. Trying to sum up what we discussed so far, if you have a building whose water flow gets interrupted because of an extreme weather event or a breakdown or something, so your municipal connection gets severed, what we've designed on one project is a day tank, which can hold up to 3 to 5 days of water. And this concept is very prevalent in India, but in the US it's somewhat uncommon because the supply of water is not at risk, has not been at risk, and then the water supply is so continuous. So let's say there's an optional rainwater harvesting connection that goes into the day tank, but let's say the water flow gets interrupted and you can use the water already stored in the day tank to flush your toilets or use very efficient fixtures and survive until the water connection comes back. All right, before we move on to materials from water, I'd like to take another break to see if there are any questions.
So right now there are no questions on water, but there was one question on, I think it was from the previous section itself. So Ms. Swati asked, how do we balance embodied energy in terms of energy usage with respect to high performance glass?
Okay, That's a great question. Glass is still, we will talk about it a little bit in materials, and glass is still a very high embodied energy material because of how much heat it takes to manufacture glass. But there are there are areas that are higher impact than glass. Let's talk about them and see if we can come back to this question at the end of the materials section, if that's okay.
Okay. So there's another question. If you have any suggestions for water hubs in educational campuses in either pre-design or post-design stage, and this question is by Mr. Bharat M.
There's not many providers who can actually help you design. It's a very niche kind of a market. But please look up a company called Sustainable Water. They're very active in the US. And one thing I failed to mention is they work with clients to come up with these water hub systems for their campuses and locations, but it's zero upfront cost for the client. So if you're a university trying to install a water hub, you don't spend $1 upfront. What happens is whatever money you save because of using recycled water on a monthly basis, on how much amount of water is recycled, you pay them that much amount of money as if you're water bill, and the company makes the money back invested in the system through the monthly payments of the clients, if that makes sense. But please look up this company called Sustainable Water. I'm sure you'll find useful details in there.
Yeah, I would like to add here, Ramana, IGBC building in Hyderabad, the Godrej Saurabhji building CIA, it has a root zone treatment plant wherein the local plant material is used to do the same what you have suggested here, the water hub. So
okay.
The IGBC building at Hyderabad, they use a little bit different thing. Like it's not like a building itself. It is like a place in the landscape where the water is actually treated by the plant material that is available, that they put up specifically for water treatment. And then once the water is treated, the water is reused, as you were mentioning, the purposes of landscaping and flushing toilets. So there is this method adopted here also, but in a different way. But that water hub seems to be a more decent and more, what do you say, sustainable and successful approach rather than this approach.
Thank you, Mr.
Yeah,
Sunil
thank
Kumar.
you.
All right. Any more questions, or can we move on?
I don't think there are no more questions. We can move on to the next.
Okay, just before we move on, I want to touch on what this slide image here is. It's the Amazon rainforest in South America, and it's one of the major rainforests on the planet. And there's been rampant deforestation going on for multiple reasons in the Amazon rainforest. And it's leading to huge loss of ecosystems and orphaning the species that are dependent on these forests. Basically, what's happening is we are losing our biodiversity, which is very essential for the health of the planet overall. And I've added these images intermittently just to add context. Architecture is important, but there's other things that are going on the site that also impact climate change. All right, moving on to building materials. Building materials, what can climate change do to the supply of building materials, right? So as you can see in coastal buildings in Visakhapatnam or other areas, the building materials have to be really durable to sustain changing climate and extreme weather events that happen with more frequency. And if you look at the construction process of buildings, there are large buildings whose construction can last over months and years. So, and if the climate is not very cooperative, then it creates very uncertain conditions for material storage on site and how you protect them from these conditions. And we still don't know fully. I mean, there's not enough research out there on how changing climate will impact building materials. So how can architecture and the building materials component respond to this changing climate? And somebody already asked the question about embodied energy and carbon. I'm glad you guys already are looking into it. But basically, the building materials used in a building have an energy and carbon footprint. And if you put a time value on emissions, they become more important than energy and carbon from operation of the building, because what you're trying to do is limit emissions in the next 10 years from going from 1 degree Celsius warming to 1.5, and material related emissions are upfront, whereas operations of a buildings will happen over the next 50-60 years. That is why how buildings are, how materials are manufactured and how clean their energy sources are becomes very critical. And if you look at the diagram on the right here, there's several stages in the life cycle of a building material, starting with resources extraction and manufacturing and on-site construction and maintenance and demolition, and eventually how the demolished materials might get recycled or reused or disposed. So usually it's not a closed loop, because we are not recycling construction waste or demolition waste so much and putting it back in the loop. We are still extracting virgin resources, and then it has to be a closed circle for things to be sustainable. And one of the biggest opportunities is reuse, adaptive reuse of existing buildings. It may be of the same type in question or not, given what a client wants, but you can always convert for example, a dormitory building into a classroom building, or a classroom building into a dormitory building, and depending on how the needs on a campus are changing, for example. And there are a lot of architects who feel like we should completely stop building new buildings and make use of the existing buildings and renovate them to meet our building space needs of the future. And designing for durability. If a building lasts for 100 years instead of 50 years, you have automatically reduced the need for a new building and the emissions it would have caused, given its demand for new materials. And if you understand what materials are readily available locally in your region, and if you specify them regularly on your projects, it means that there's less emissions related to transporting the materials from where they're extracted and manufactured to the project site. And specifying materials with low carbon footprint. There are some materials that are rapidly renewable or take much less energy compared to other materials to manufacture. So if you keep an eye on specifying materials that naturally have a lower carbon footprint, or maybe originally they are of high carbon footprint, but the manufacturer has completely converted to renewable energy for their manufacturing plant, in which case it becomes a material with low carbon footprint. So specifying those regularly would help. And salvaging materials from when buildings are demolished, we talked about it in the life cycle of projects, and reusing them. For example, in this picture, you can, on the top left corner of the picture, you can see a roof condition with a slate tile on the roof. So when that building was demolished, the tile was collected and stored in a warehouse in the middle of the picture and reused on another project. I'll touch on this a little later. And there is a process called lifecycle assessment, which looks at the different stages of a product. of a building, right? There is the product stage, which is called cradle to gate, which is the extraction, transportation, and manufacturing. And then there's the even construction process has an energy and carbon footprint, so which can be optimized. And then the use stage, where the building it has been constructed and there's maintenance of the building, and each of the equipment in the building has its own life. For example, light fixtures might have a life of 10 years. Air conditioning might have a life of 15 to 20 years. And if the building is 100 years, then you're regularly replacing those systems inside the building. And at the end of life, what happens? We talked about demolition or recycling or reuse, and so on and so forth. So you can use this process of life cycle assessment to optimize the embodied carbon footprint of your entire project. And summing up what we've discussed about materials so far, there is a product selection involved regardless of whether you're building a new building or reusing an existing building. And the goal here is to optimize the embodied carbon. And when optimizing the embodied carbon, if you can only do one thing, given the fee and time available, focus on the structure of the building, because the structure is 70 to 80% of the carbon footprint of the entire project. And if you can, then move on to the envelope, which is the load-bearing walls, or the external walls, or the window framing and the window glazing. Somebody asked a question about glazing. So and the interior finishes and whatnot, partitions, they have a 20% to 30% impact. So if you focus on the structure, you'll get more bang for your buck compared to the other things. All right. The next section is summing up, but I want to pause here to see if there's any questions.
So there's a question by Ms. Harini. She's saying that glazing and concrete has become inevitable in high-rise construction. Can you, however, suggest vernacular and traditional building materials, particularly for high-rise development in Indian context? And how far is it workable?
Okay, I think the case study I'm going to cover next sort of touches on that, but it's not in an Indian context. Please take that information and see if it's translatable to India, or if there's comparable information available for Indian context.
Okay. There's another question by Ms. Shobha, and she's asking, for old buildings, how far is it possible to retain and use natural sustainable strategies for reusing the existing material, I guess?
So it's about reusing old buildings that may or may not be in good condition. Is that the question?
I'm not very sure. Ms.
Okay.
Shobha, are you here?
Shobha can unmute and ask the question.
Hello.
Yes, ma'am.
Good morning, ma'am.
Yes, ma'am. You can ask your question.
So how we can use the reuse, that is existing reused material for the next another building? How it can be used without disturbing the natural strategies? Are you getting? Hello.
Yeah. So I'm trying to understand the question and give a useful answer here.
How the existing building having so many things are there, sir. So how we are maintaining the same things using for the another building?
Okay, so there's non-structural uses in the newer building, right? That can take filler material.
Yes.
So for example, brick demolished from a wall doesn't have to go into a load-bearing wall. It can go into a paving material. And this project I'm gonna talk about shows you some other examples. I mean, I already talked about the slate tile from the roof becoming an interior tile inside the building. And there's one more example of wood members, where they come from and how they get used in the new building. So hopefully that'll answer your question, but if not, we can circle back to this question at the end.
Okay. Thank you.
All right. Emma, is there anything else?
Just one more question from Mr. Bharat.
Uh-huh.
Please suggest if there are any global rules that we can adopt for using materials, building materials like ashray.
Yeah, ASHRAE applies to MEP systems, mechanical, electrical, and plumbing. But I think materials are such a local thing that it's hard to have a global standard. But I remember seeing a huge compilation of materials database by the World Bank and the IFC for the EDGE certification system. I don't know if whoever asked the question is familiar with EDGE certification for buildings. I think it's prevalent more in India than in the US, but the World Bank or the IFC website has a huge report outlining what the carbon footprint associated with different material types are. And maybe it's applicable to a very localized region or not, but I would suggest whoever asked the question to look up that report to see if there's anything useful.
Okay. I think we are done with the questions on this session.
Yeah, I think there is one publication by BMTPC which talks about all the available building materials, okay, natural and the manufactured, wherein it gives in details about the embodied energy and the scope of their use as an energy efficient choice. I think there is one publication by BMTPC, the Building Material Technology Promotion Council. Maybe if we can refer to that, there will be a lot of answers with respect to a lot of building materials, choice of building materials.
Okay, I'm taking
There's
a note
one
of that.
addition from one of the participants. She says that CEPT Ahmedabad has a standard reference on thermodynamic properties on Indian materials. I think that would be a very good resource. So we can look that up too.
Okay. If not, maybe, it can be a thesis project of a student or something to do something that's relevant to whichever location
right.
they're working at. So
yeah, definitely. Thank you. So I think we can move on to the next session.
Okay, so we've looked at what the problem is and what the role of energy, site and water and materials can be. So I thought bringing it all together using a project case study would be useful. This project is called the Candida building. It's in Georgia Tech's campus in Atlanta, and it's a higher education building. It's about 40,000 square feet with classrooms and labs and interactive spaces and whatnot. So I want to go through this case study specifically with all the issues we discussed in mind to see how one project can implement all of these. All right, it's in Atlanta, Georgia, in the USA, where on the campus of Georgia Institute of Technology, which is also called Georgia Tech. And this is all the architecture and engineering companies that have worked on the project. So just to give them all credit, it's not just my employer. And there I am in the yellow rectangle. These are all the people who worked on the project, design and construction. So I'm just one of the different specialists who worked on the project. It wouldn't have been possible without the collaboration of all these great, experts. So what it does is it uses a certification system called Living Building Challenge. Living Building Challenge is a philosophy. It's a certification system. It's an advocacy tool. But it's if you take LEED or EDGE and make it 100 times more stringent or rigorous, you will get Living Building Challenge. It has 7. It follows the model of a flower because a flower is so self-reliant. And the 7 categories in the certification system are called petals: place, water, energy, health and happiness, materials, equity, and beauty. So In certification systems like LEED and EDGE, you have some things that are optional, you have to do, and some things that are optional, and you get points for doing the optional things. And greater the number of points that you earn, the higher your certification level is, like silver, gold, or platinum. But here, you have to do everything. Nothing is optional. And there's 20 combined, under the 7 petals combined, there's 20 imperatives. These imperatives are comparable to credits under LEED, and you have to achieve all of them. So for example, under energy, you have to be net positive energy use. This is above and beyond net zero. So for example, on an annual basis, you have to at least produce 5% more energy on site compared to how much you consume. And water, you are not supposed to rely on the municipal connection. You have to be in a harmony with your surroundings and produce all your potable and non-potable water using rainfall and any other recycling and any other means, just as an example. And we'll see in detail how the project has. So it's like I said, it's about 40,000 square feet. And the programming of the building, and it was meant to be net, just like the previous sections, I'm going to look at energy, water, and materials. And the programming of the project was based on the amount of solar energy available on the site, the solar energy potential of the site. So these are not actual numbers, but for example, if you have 68 units of energy available from solar, and you have a single floor building, then you can, design it all to be 68. And if you have 2 floors, 34 and 34 and so on. So it's unusual, but your building's energy usage is dictated by the budget of energy available. And like we discussed earlier, start with passive measures. And this is one of the very few buildings that I've seen that has Venetian blinds on the outside of the windows, not inside. So you're blocking radiation from falling on the windows. It's triggered by a local weather sensor that tells the building when sun is falling on which facade of the building. And the exterior blinds are automatically, usually they're retracted and you can't see them. But when the sun is falling on the facade, they get deployed and they block direct solar gain. So they allow daylight to come in, but they block direct solar radiation and glare. And if you cut a section through the building, you can see here, obviously the east windows have the exterior blinds, but on the west, you have a huge extension, and it's called the porch, that not only creates tempered outdoor space for people, students and visitors and faculty to hang out, but also it shades the windows of the west-facing facade. And you can see the porch in this picture better here. So the section is cutting through the width of the building there. And on top of the east and west treatments, there's skylights and clear story windows in the middle, which brings in daylight. And I believe there are about 70 ceiling fans in the entire building. And the ceiling fans redistribute the air conditioning and decrease the need for air conditioning in a way. And they provide passive comfort, which is useful in reducing the load when there's power available. But if there's a loss of power and the air conditioning doesn't perform, then the fans by themselves can, in combination with the shading and the operable windows, can provide comfort. And this was a very initial energy analysis conducted on the project. And even when we were interviewing for the project, we didn't even win the project by then. But the leftmost bar is the baseline of all the existing buildings that are comparable. So the energy use intensity, which is kilobTUs per square foot per year, of all the existing building stock comparable to the building in question, was 83. But if you had to design a new building that barely met the energy code of the region, your energy use intensity would be at 51. But what if, on top of barely meeting the energy code, you use a radiant heating and cooling system where hot water and cold water pipes are running through the floor slabs, and you connect it to a ground source heat pump? Your energy use intensity comes down to 19.4. And for people who are not familiar with energy use intensity, it's somewhat comparable to miles per gallon in a car. It tells you how efficient the building is. And instead of radiant system, if you used a variable air volume system with low pressure drop, and you connect to the campus central plant instead of designing a local heat pump system, then your EUI is still in the same range of 20. And having photovoltaics generate 10% more power than needed would put your EUI available at 22.4. And there's some other measures that have been studied, but you can see what could have been 83 is now at 20, which is roughly 75% reduction. And as we progressed on the project, we did more detailed energy modeling. This chart is too busy and it has a lot of information. But can you, Hema, can you see my cursor if I point to something?
Yes, I can see that.
Okay, that's awesome. So for example, this is the base case where you start with the minimally energy code compliant building. And then what if you applied revolving doors on the base case, right? Your revolving doors reduce air infiltration compared to doors that open and close swinging doors. And that's an individually tested measure. And relative humidity allowed to go up to 60% or limited to 60%. And what if instead of double pane glazing, you use triple pane? And what if you double the insulation in the roof and the walls? These are all individual measures run on top of the baseline to see how much the reduction they cause. And what if you use Venetian blinds on top of on the east and west windows, right? And you take one bundle of them and create one proposed case and another bundle of them to create a proposed alternative to see which one is more acceptable. And for here, you can see the number of solar panels for each of this case. The direction is reversed here. But on the x-axis, you can see the number of solar panels needed to meet a certain design situation. So for example, if you went with instead of proposed alternative 1, and you drop down here, you see roughly somewhere between 850 and 900 solar panels are required. So because it's a net positive or net zero situation, you also have to keep an eye on how much impact for the solar panels is. Okay, done with the energy here, moving on to site and water. There's different natural regions in Georgia, and this geographic region is called the Piedmont Forest. So the immediate site and the overall context of the project mimics the behavior of the Piedmont Forest in terms of how the water flows on the site or what kind of natural species have a habitat in this region and whatnot. So that defines the context of the building. So there's 3 scenarios on what happens to water when it, for example, when it rains. In the pre-development time, I mean, if there were no buildings, most of the water would infiltrate into the ground, and some of it would get surface discharged and flow to the adjacent regions. But today, the way we design buildings, most of it goes into the storm drains and goes into the city sewage system, and very little infiltrates naturally, like it happened with pre-development scenario. And in a living building, the way we were designing this building, by the way, this building has been operational for slightly more than a year now. The way this building was designed is to mimic the pre-development situation where most of the water will get infiltrated. Some of it will be discharged on the surface, but a lot of it will be used to create a net positive water consumption situation, as is shown in the diagram. And this is another view, plan view of the site that shows the different kinds of water flow on the site and the different kinds of payment systems that exist. There are other diagrams that explain this better, so I'm going to move from here. And if you cut a section, for example, the porch area, this pervious unit pavers with the stone base that let the water infiltrate and not flow away like a typical concrete surface. And between that and the walkway, there's all these. One of the requirements of Living Building Challenge is a certain percentage of your site has to be for urban agriculture, and you have to produce food for human or non-human consumption. So these food types were identified as being native and useful to the local life forms, and they were interspersed between pervious concrete and unit pavers and whatnot, and integrated into the landscape of the project. So here's another diagram showing different water systems on the site. There's a lot of detail. Don't try to read all of it. But this gray water treatment we talked about, which comes from sinks and bathtubs and whatnot. And there's rainwater to potable water. Remember, even the drinking water comes from rainwater on this project. And this condensate harvesting. So air conditioning systems, when they remove moisture out of the air to cool it, that water condenses, and it's a very pure form of water, which still requires a little bit of treatment, but you can create water through recovering condensate on the project. And here's another diagram that shows different types of surfaces. On the top left, you will see a green roof surface, and to the top right, you will see the solar panels, which not only double as surfaces capturing rainwater and funneling them down into the building or on the site. And the blue areas on the site are porous unit pavement, like we talked about at the porch. And at the walkways, the gray areas are the porous concrete pavement. And another level of diagram shows what's happening with the water on site. All the blue boxes that you see on site is where the water is stored to either to reuse or to infiltrate. I mean, slow down the flow of rainwater from the site. It's stored here. Pardon me? Okay. And did somebody say something?
No, I think you can continue.
Okay. So you store it and gradually release it on the site to improve infiltration, as opposed to all the water flowing away from the site. And all the green areas are the landscaping or bioswales or natural rain garden systems that will actually hold the water and infiltrate it. And we've already talked about the porous pavement systems on the site. So that was site, but what happens inside the building? Let's take a snapshot of one scenario here. On the right, everything is the same, efficient fixtures, but your toilets are regular toilets that need to be flushed. And on the left, you replace the regular toilets with composting toilets, which use like a tablespoon of water and soap per flush. So you immediately, the size of the pies is indicative of the amount of water that the project is using. So just for toilet usage, what would have been 8,000 gallons? 1 gallon is roughly 4 liters. So what would have been 8 lakhs gallons has been reduced to less than 1 lakh gallons for toilet usage. And this is also a money saver. Over the life of the project, because you're not using all that water. And there's, like we discussed earlier, there's also gray water treatment on site using natural systems. And the treated grain, the captured condensate and the treated gray water are reused for irrigation and whatnot, and there's no flushing on the project. But the drinking water mainly comes from the treated rainwater. There's about a 50,000 gallon room in the basement, which is a cistern that holds all the rainwater, which gets treated and circulated for drinking water purposes. I think I missed a slide here. Maybe it's better to skip it at this point. But we've talked about energy and water. Moving on to materials. There's about 20 or so red listed materials that are to be avoided completely on a living building. And for example, formaldehyde is one of them, and PVC. No PVC piping or any material, any product using PVC on the project at all. So those 20 chemicals, if you take all their variations into account, become 700 some chemicals. And we went through a detailed process to make sure we researched all the products available in the market. Either you avoid the chemical, or if you're forced to use it because there's no alternative available, you have to do advocacy on writing letters to the manufacturers, urging them to remove those chemicals from their products. And for the structural system, like we talked about, structure is about 70 to 80% of the carbon impact on the project. And concrete, if you apply carbon footprint to these different structural systems, concrete had the highest carbon footprint, followed by steel, which was the second highest, and wood, which is actually used on the project for structural systems, actually had a negative carbon footprint because, one, it's not as intensive in terms of manufacturing compared to cement and concrete and steel. And it also acts like a battery for carbon, and it stores carbon over the life of the building. So its carbon footprint is actually negative. So for this reason, timber was the chosen medium of structure for the project. We talked about slate roof from a different demolished project becoming a bathroom tile for this project, and granite slabs from the demolition of another project becoming stone curbs on this project. And to the left, you see images of joist wooden structural members from another building that was demolished, and they become stair treads on this project. And on the campus, some of the trees fell because of storm conditions, and those trees were cut up and converted into countertops for this project. And on the left, you see lately, because of all the tax rebates that Georgia was offering for all the movie industry, Atlanta had become a huge movie shooting hub. And all the wood that is used for temporary structures on the movie sets is waste. And we took a lot of it and converted it into ceiling roof decks on the project. So if you see, there's some deeper members and there are shallow members. The deeper members are structural, but the shallow members are just fillers. And the shallow members come from the reused joists. Again, looking at the living building challenge, you have to do net positive energy, you have to do net positive water, and the building has to be located in its context. But it forces sort of an integrative process and says, okay, you're doing all that for resources, but you also have to make sure the building is healthy. And the materials we already talked about, but building has to be equitable to all kinds of people, and it has to be beautiful. So as you design resource efficient buildings, or teach your students to design resource efficient buildings, just it's good to keep in mind that you have to combine all the aspects and make sure it's a successful architectural example. Just to quickly recap what we've looked at: problem definition, role of energy, role of site and water, role of materials, and we used a case study to see how all these things come together. And that's all I had for today. So if you have time for final Q&A, Hema, I'm open to questions.
Yes, if anyone has any questions, please type in the chat.
I saw some questions pop up while I was talking. I don't know if people already typed something or not.
They were not specific questions.
Okay, okay. Well, if there are no questions and if something comes up to your mind, Hema has provided this email address to send questions to, which can be answered at a later date. But I really appreciate the opportunity to discuss such an important topic with you all. Thank you.
Yeah, Hema, there is one question by architect Tania Bira. Wood has negative footprint, but where wood is not available in plenty.
Okay, is there more to the question? Sorry.
Yeah, that's all. She wants to understand why wood was used in this particular building when maybe in our case, maybe in India, wood has a negative footprint.
Yeah, so like the ecosystems we looked at, like the Borneo rainforest or the Amazon rainforest, the goal is not to extract wood from old growth forests like that. Obviously, how you extract wood and where you extract it from matters a lot. So in the US, there's a growing industry that produces and harvests wood purely for construction. So I know it's culturally different from India, and I don't know what's more environmentally friendly in India, but there is consensus here that sustainably produced and harvested timber has a better environmental impact or positive environmental impact compared to steel and concrete. I mean, if all the buildings were built of wood, would it still be the case? I don't know. But for now, it seems to be a better way of doing things. I can't say that's true for all locations.
Yeah, if like most of the wood that you have used in this building is recycled wood, and wood you have harvested because of that damage of storm. So if it is in the same case, like similar case in India also, I think that would be a better sustainable material if you are salvaging wood from other buildings, or if you are reusing some other wood material from other resources. So even Vishakhapatnam, when Hudhud happened, there was so much of trees that fell. So that wood was reused, and there were a lot of teak wood trees and other trees which were very suitable for construction. So that salvaged wood, using them is definitely a sustainable option rather than concrete or steel for the same kind of solution. Yeah.
Thank you.
And I would just like to sum up, Ramna, your work, the presentation that you have done. It was very meticulously done in 1.5 hour, less than 1.5 hour. You have actually summed up everything about a building as an architect, how we have to look, and basically the new challenge that you have actually sorted out in Kendall building, the living one,
Building
like
challenge,
living building challenge, that seems to be more appropriate than these LEED and other systems, because whenever as an architect, whenever we think about all these LEED and ECBC, all these contexts, we definitely feel that they are not being done for a building, but they are being done for some commercial gain. Many of the architects feel that these green buildings and all these are also like have a commercial end goals rather than actually as an architect responding. But this one definitely seems to be a all compassive and a challenge, real challenge for an architect. see, from net zero, now we are talking about positive net, right? So the buildings are producing energy than what they actually require, and then they have to be healthy. And now the urban forestry, that is a part of the building itself, where you are urban farming as a part of
Yeah.
your building design. All this seems to be definitely a better sustainable solution than the other forms of green building concepts that we actually are working on. So definitely uh, this as the first session wherein you have actually given a very broader scope for all the architects to be more attentive, rather than just looking at solutions to some problems. Rather than that, like building being a not only just solution to problems, but more than that, I think all the architects should keep in mind while working. And I'm sure that this presentation would definitely give them a direction to work on more than what the problem seems to be. Yeah, thank you
I'm,
so
I'm,
much for
I'm really happy the message came across, and thank you for the opportunity.
yeah. Yeah, Hema, I think you can ask anyone from the participants to speak if they want to speak their mind, because we have 10 more
Yes,
minutes. Yeah, we have 10 more minutes.
there were a few questions, but I think we can mail those questions to Mr. Ramana, sir.
Yeah. Yeah.
So anyone from the participants want to talk?
Yeah, please, anyone from the participants, you can, there are few more minutes time, and we have Ramana with us. So you can just uh, share your thoughts.
One thing, maybe nobody has asked, but I would like to add is, please include all the disciplines in your design process. Usually the architect designs the building and then gives it to the landscape architect. They design the landscape and you pass it on to the mechanical engineer who designs the mechanical system. That is a more traditional or a conventional way of doing things. In an integrative process, you include everybody, and the site and the building are more seamless. They're more integrated. And the mechanical system informs the architecture informs the mechanical system design, and there's a consensus on how best to use resources and make a better project. So take advantage. I guess tell your students to take advantage of all the other disciplines and not make them secondary in a way.
So I see a few participants unmute themselves. So someone wants to talk, they can talk.
Hello, can you hear me?
Yeah, Anuj.
Hello.
Yeah.
Good morning, sir. My
Yeah.
question is for Raman, sir.
Hello.
Sir, wood is not going to be that stronger as concrete. So will wooden structures are feasible in today's scenario, seeing the various frequent hazards in our country is divided into various disaster zones for earthquakes and like structures. So will these wooden structures will be feasible in India?
So I don't know if you've heard the terms, but they're called mass timber and they're called cross-laminated timber. So there is a structural aspect to wood. Regular wood may not be structurally sound, but one, there is wood available which is structurally usable. And they take these panels and then they combine them. The way they make composite panels out of the wood definitely lends themselves to structural uses. But if you noticed in the example, there are situations in which if you purely use wood, the depth of the beam will not leave any space for head height. So you can combine wood with steel. So you're reducing the amount of steel and using some amount of steel bracing, but wood is still the majority of the structure. So there's different. If you talk to a structural engineer, I guess they'll tell you a few innovative ways of doing things. Does that answer your question, Anuj?
Yeah, thank you, sir.
Sir, can we take a group picture?
Yeah. It is mandatory, isn't it?
Yes. So I request all the participants to please turn on your videos for a bit. We'll just take a group photograph. I mean, a snapshot.
It's mandatory for AACT. We had to submit. So, yeah, I request everyone.
Sir, Sunil, sir, you also.
Yeah, myself, I know. Okay. Yeah, architect Satyanarayana and Shinana Sayonara. Yeah, Hema, I think there are 3 galleries that you had to take. Okay.
I'm done. I really thank Mr. Ramana Koti for his time. I know the kind of adverse situations he worked on during this presentation. They were having a cyclone. Was it a cyclone?
Yeah, hurricane. Yeah.
Hurricane. I'm sorry.
Yeah.
So amidst of that, he worked on his presentation and he could find time. It's actually quite late for him, being in the US. I think it's midnight. But thanks a lot, sir. And that's a very useful presentation. It set the right tone for the rest of the workshop, faculty development program, and a very good example that you're shown. Thanks a lot. Our next speaker is also here. Dr. Janmijay Gupta is here. But since this presentation just ended, we'll just take a quick 5-minute break. And by 11:30, if you can come back, we can start the next session. Thanks
Good
a lot.
luck.
Thank you, Ramnas, for your excellent presentation, which has set the tone for the whole FDP for the next 5 days. Thank you so much.
You're welcome. Bye-bye.
Bye.
Thank you. Welcome back. So I hope all the participants are here. I would like to first give a brief introduction about Dr. Janmajay Gupta. Dr. Janmajay Gupta is the head of the department and an associate professor in School of Planning and Architecture. He is an architect and an urban planner, and he worked for over 15 years in the industry, and he was also teaching for a while. He acquired his doctorate from in architecture from BIT Mishra, and Dr. Gupta is presently working on several extensive research on passive design strategies for thermal comfort in dwellings and sustainability in urban planning. He's an IGBC professional and has worked on number of green building documentations. He's an editor for the special issue of Journal of World Architecture and an editorial board member for several journals such as International Journal of Architecture, Arts and Applications, International Journal of Sustainable Building Technology, and he's also a life member of Indian Institute of Town Planners and Indian Institute of Architects. So he's going to give a presentation on vernacular architecture today. So we are very happy to have you, sir. You can.
Yeah. Am I audible? Architect
Yes,
chemistry, am I audible?
yes, sir. You're audible, sir.
Okay, my presentation can be seen?
Yes, sir. We can see it.
Okay, so warm good morning to all the participants. It's a privilege to be speaking here on this topic. Now the theme of the conference is very, very relevant, of course. Climate change, or rather the theme of the FDP is very, very relevant. It's climate change and adaptive architecture. And in context to the theme of the FDP, I'm going to give two presentations. First in the pre-lunch session, that is on vernacular architecture, and the second one in the post-lunch session, that is on climate responsive architecture. Now, where does the vernacular architecture stand in context to the thing about climate change and adaptive architecture? That is the first thing. So the thing is that vernacular architecture is, of course, in today's context, we can't practice it the way it was practiced, say, 50 years back, 100 years back, and even further back. But of course, we can learn the lessons out of it. And that is where we are missing a trick. Because vernacular architecture was intrinsically climate responsive in nature. And all that our forefathers did with respect to vernacular architecture was that they developed their architecture in response to the climate. And climate change, for that matter, is not a new thing. It's been happening, and it will happen, and it had happened before. We even actually had more major climate changes before. It's now that we are more aware, maybe, or we think we are more aware that we are paying more attention to it. But even though we are paying much attention on it, on ground, we are doing very little, actually, unfortunately. So our forefathers also realized it. And by the way, at that time, mechanical ventilation and HVAC systems were not at all that developed. They are a very recent development. I mean, something over the last 100 years, actually, they have developed, basically. So, and at that time, our forefathers understood that, and they concentrated on making their dwellings in such a way that they adapted to the climate existing and to the climate that they foresaw would change. So they were ahead of us in that way, actually. Now, in today's buildings, what we are doing is we are more or less 75% of the fresh graduates, you ask them, they will design not in response to culture and climate, which is a cardinal sin, actually, in architecture. If you're not taking into context the prevailing climate and prevailing culture of the place. So it is in that context that vernacular architecture finds a place in this FDP arranged by Geetam Hyderabad on climate change and adaptive architecture. Climate is changing. It will change more. Sea levels will rise. A whole lot of factors are going to happen. Fine. But our architecture also needs to adapt. So in that adapting, what role does vernacular architecture have? We have to take the lessons from vernacular architecture and reinterpret them and use them in a modernistic way. That is where the role of vernacular architecture is important. Because if we keep constructing concrete containers, be it in Prime Minister Awas Yojana Rural, and be the site in Kanyakumari, or be the site in Ladakh, or be the site in Assam, if we blindly keep constructing those standard prototype Prime Minister Awas Yojana prototype concrete containers, it is not going to help us in the long run. Definitely not the people who cannot afford mechanical ventilation, and also from the energy point of view. Because as we are well aware of, and as was also mentioned in the previous presentation, you know how much energy cement and how energy intensive materials cement, we all know it, concrete, all of them are. So the thing is that it is in this context that vernacular architecture still has a role as we move into a future where vernacular architecture actually is becoming more and more irrelevant, because there have been numerous surveys carried out in which people have point blank said that they don't want to live in mud houses. They want concrete houses, they want brick houses, be it containers, and people themselves, paradoxically, they themselves have said that we don't want any link with culture, you just give us a dwelling place. But this perception, because they are ill-informed, because they are not knowing that this in the long run will harm them, this in the long run will prove to be a problem, that's why they are not appreciating. That's one reason I identify as why vernacular architecture has been rejected. The second reason is that we are not updating our technologies on a mass scale. Yes, for example, with respect to mud architecture, Auroville and some other isolated places, they are doing great work. They are modernizing earth architecture. Even Gopal Shankaran in Kerala, Habitat International, even before also Sir Laurie Baker had done, and in present day among the living architects, still practicing architects, Gopal Shankar sir, and then you have Auroville, great work been done at Auroville also. But those are isolated examples. They are not spreading across. They are not being adapted uniformly. People still have a misconception that mud is only about cob mud, which is lumping mud over mud, or it's wattle and daub, which is you use bamboo, and you plaster mud on top of it. So that's how their mud construction is limited to. Their ideas of mud construction is limited to. So that is the main thing that we as architects are guilty of. We are not allowing desensitizing people about the proper ways in which mud is used as a construction technology, the ways in which mud can also create low-cost economical solutions for at least instead of the concrete containers we made in the name of PMAY rural at present, which are totally alien to the climate of the place and totally alien to the culture of the place and totally alien to the existing building materials of the place. And it's not only about mud. We have so many different materials, vernacular materials in all the different regions of India. We have stones found in abundance some areas. We have mud found in abundance in some areas, and they are all consistent with the climate of those areas as well. And they are also consistent with the culture of those areas. So it is with this backdrop that I'm starting my presentation. And the presentation, of course, is themed as vernacular architecture and its importance or its role with respect to climate change and adaptive architecture. So I move on to the next slide. Now, we have to learn what vernacular architecture is, though we all know it, but still, I mean, vernacular architecture is something that has evolved through consistent and continuous effort. It's something like a wheel. Now, today we have our fancy cars and our fancy wheels. We have MRF, we have Fiat, but someone first made the wheel, right? Long millions of years back, maybe someone first made the wheel. And I tell you, it was a very difficult task to make that first wheel. So, and since then it has evolved. So vernacular architecture is something like that. It shows how early man himself was an architect. It also shows that man himself is a born architect well before this profession actually came. in a formalized way. That shows that man by instinct is an architect. So it was evolved by consistent and continuous effort for efficient solutions. And the number two thing about vernacular architecture, important thing is that vernacular architecture of any place is known for its respect to climate, with respect to use of certain passive methods for a comfortable indoor environment. The term vernacular itself has been derived from a Latin word, which is vernaculus, which means local, and many well-known publications and authors have referred to vernacular architecture as a native science of the building. So it's original building science. I mean, building science today has, of course, become much more complex and much more high-tech, but from where it all began, it's the original building science is actually vernacular architecture. That's how important it is. And that is the reason why we should go back time and again to take some pointers from vernacular architecture. That yes, we need to learn this and unlearn this part of our modern learning and learn that particular part of vernacular architecture because it was the original building science. Now, almost all the countries globally have some sort of vernacular architecture. For example, at least in developing countries, till today, much of the population remains in rural areas, and they have their own typical types of traditional buildings and technologies to use. And of course, with growing economic power, with growing economic improvement of people, they want to upgrade their traditional and vernacular houses. Now, many well-known people like Meyer and Rofe and Asquith and Wellinga, they have all studied extensively on this, and they have compiled a very knowledge-based body of work on the same. Now, of course, again, most of us would be aware of it, but it still needs to be pointed out that the main determiners of vernacular architecture are climate. Yes, climate, of course, number one. Number two is the locally available building materials. Now, this is something, point number two is something we are grossly neglecting in present day. I still feel our first choice as architects, even when we are doing live projects, is that we should source the locally available materials. Why? Even our GRIHA ratings, even our IGBC green ratings, they have this, that you source your materials locally. They have some points for indigenously sourced materials and all those things. So I think that's somewhere we are going wrong on. Third is our indigenous construction techniques. Again, India is very rich in indigenous construction techniques, which can be reinterpreted, which can be re-evolved into modernized techniques, modern ways, and used. But somehow we are missing out. And of course, fourth, all these four are equally neglected actually in present day Indian scenario. Most of the cases, of course, I'm talking about. Where our local customs and social traditions, which are neglected. We are not looking into them. We are not looking into and giving importance to them. And you know what happens if we neglect the cultural practices of those people, then the future generations, they lose touch with their roots, and that is detrimental to society. They try to adapt to a culture that is alien to them, and once a person loses his or her roots, then it's much more difficult for him or her to stay grounded, to stay on the right path. I mean, it has actually social implications. If we start putting all people in concrete box containers, glass and box containers, it's not going to help our society in general, because we have been brought up in a certain way. And yes, it's very desirable. We get educated, we get enlightened, but we have to stay in touch with our roots, cultural roots. Now, vernacular buildings are inherently a sustainable way of life. They inherently promote a sustainable way of life. They are what sustainability is all about. So vernacular buildings are synonymous with sustainability, if we may even say that. because vernacular buildings, all documentations of vernacular buildings that have happened through history have shown that these vernacular buildings record lifestyles of the past. They record what people did in the past and how they lived. And because, as I told you at the beginning of this presentation, this climate change is something which is not happening today. It has happened before also, and it has happened with major implications before, maybe actually, or equally major implications as in it is happening today. So then also people found out a way in which they had to survive and not perish. And that is, therein lies the importance of vernacular architecture. There's a lot of ecological lessons which we can learn from vernacular architecture that happened at that time. Now, there's a lot of you must be aware of the famous publication House, Form and Culture by Amos Rappaport, exceptionally good book on this subject. And even he has clearly mentioned that after extensive studies, he found out that in vernacular housing, actually climate and culture are the two most important determinants, because materials, construction and technology are there, but they are at best treated as modifying factors. I mean, they are add-ons, but the crux, the heart of vernacular architecture lies in climate and culture. It is climate and culture that decides vernacular architecture, and it is climate and culture which mold and has molded vernacular architecture all through. Now, what the add-ons basically do, like materials, construction techniques, and technology, what they do is that they modify that fundamental organization. They offer you some more alternatives where it rains very heavily. You have those sloping roofs which project out, and for the extra projection, you have some indigenous technique of support when the projection is made beyond a certain limit, as sometimes happens in the rainy parts of our country like Assam. And again, then there are technologies related to raising the level of your building up a little, stilted, as they say, in Assam, where it's prone to flooding. So all those are add-ons, but it's basically the climate and culture. That's what has molded and guided vernacular architecture and has helped determine its form. Now, whenever we talk of a building, the first thing that comes to our mind in general is the form. I mean, we begin with the form, though we of course pay attention to the function. And as the famous adage goes, that form follows function. But somehow, psychologically, we are tuned to think of the form at first. The first image you have as even when we were architecture students, the building form. Yeah, that's why nowadays students also, they are working on SketchUp so much, because they want to see before they actually design it. Also, they want to see. Sometimes that's a very wrong method, but that's the thing. So this form determinant, Rappaport was very unanimously clear about it, that form determination is done by climate and culture. The others are at best modifying factors. That is as per him in his famous work on the same about house, form and culture. And it holds equally true today. Now, the first job we have as an architect is to recognize vernacular values. First, what to take from that vernacular architecture and what not to take. I mean, we can't blindly go back 50 years, 100 years, 200 years. No, it can't be done in today's high-tech world of intelligent buildings. But there are some things which we need to take. So the first thing is to need for recognizing vernacular values. Now, some things that vernacular architecture does very well is orientation of buildings. Of course, we also know it, but unfortunately, even after knowing, I can show you dozens of examples in real life architecture where buildings are not even oriented properly. I know there are other factors where architects are not free to orient their building as they wish to in many cases, but still, that's the job of an architect, to find out the best fit solution. And sometimes we are guilty of not doing that. Internal arrangement of spaces in a lot of vernacular housing all around the world is exceptional. The use of courtyards, that's something we need to learn from vernacular architecture, where to use internal courtyards, for example, maybe hot, dry climates, where to use external courtyards, maybe in climates which are a bit windy, which are hot, but warm and humid, but there's an appreciable evening breeze. And we need to orient those courtyards in the appropriate direction. Somehow at that time they did not have all these wind direction measuring devices and softwares. They did not have Ecotech, they did not have climate consultant, they did not have weather files, but still maybe instinctively they used to orient their courtyards correctly. And as you must be knowing, in areas where there's an appreciable air movement in evening, at least in our hot and humid parts of the country only, I'm saying, there it's never the correct solution to orient your building perpendicular to the incoming wind direction, predominant wind direction. The rule is always to ensure that our building and the incoming prevailing wind direction make an angle of about 30 to 45 degree or 20 to 45 degree with the incoming wind direction. Somehow in many vernacular dwellings, it has been found that they got these things spot on. They have created that angle, they have placed the courtyard right where the wind is coming in. So that's amazing how they did so long before actually. So other than thermal comfort, vernacular architecture also gives a number of pointers towards betterment of architectural quality. Now, of course, you may argue that why in this today's industrialized age, our architecture, construction, and all these materials, we are using the best techniques and many things are prefabricated. What pointers do we need from vernacular architecture? No, it's not in terms of the material and how it's produced. The architectural pointers towards betterment of architectural quality that I am saying are with respect to planning principles, aesthetics, and building materials used in the built form. Very important. We are somehow lacking. We are lacking in aesthetics. Unfortunately, even though we think that our buildings are looking great, somehow many buildings are an eyesore. Then also planning principles. We are negating certain basic planning principles, maybe due to real estate needs, maybe due to our builders' pressure. But whatever reasons, we are negating. End of the day, we are negating. And as architects, that's not something that we are supposed to do. And again, as I told you, building materials, we are not using the correct building materials in many cases. There are alternatives, modern day alternatives. I'm not telling you to go back to mud, actually, or bamboo. Modern day building alternatives, the locally available stones, locally available building materials, hybrid building materials. We are not using them in a lot of cases, which is appropriate to that particular context. So these are lessons we need to learn from vernacular architecture. There is a need for recognizing vernacular values by incorporating them into our contemporary built forms. That is the end line. I mean, that is where all our energy should be focused upon. So I'm going to talk at a glance about these topics, and I'm going to take examples of 3 different places in India with varying climate. So this is the places in India that I have taken. If we start from top left is a map of West Bengal, which is my home state, which is where I was born. But I've studied and worked my entire life almost outside of West Bengal. But it happens to be that West Bengal is my home state. So West Bengal, again, is a unique state. To the north of it, it has Himalayas, Darjeeling and Kanchenjunga. They are very near to West Bengal, but Darjeeling is in West Bengal, actually. And then in the middle, you have the plains, the Ganges plain, and that. And at the bottom, you have the sea. So you have, it's sometimes people say it's a microsome of India. It has got all types of climate. In the north, it gets very cold. And in the south, it gets very warm and humid. And in the middle part also, it's pretty tropical type of climate. Maybe a bit less wet than the south, but tropical nonetheless. So that's one of the areas where we are going to consider West Bengal. And then the next example, where in the blue map of India, in red it's indicated, as you can well understand, that is Kerala. That is a second example that we are going to study. And the third example we are going to study is a hot, dry climate. The first two were warm, humid, more or less warm, humid. Kerala is fully warm, humid. Bengal is mostly warm, humid only. And some parts tend to be a bit dry, but end of the day, they are also warm, humid only, because it rains a lot in Bengal also. And the third example we are going to study, as it can be indicated in the bottom left, is Gujarat, where we are going to study about the Kutch area and the Great Rann area, the hot, dry desert climate area of Rann. And that's a third area of study in trying to understand how we can take pointers from vernacular architecture and how vernacular architecture has evolved in all these three places, and how vernacular architecture has actually contributed and can contribute to the modern day architecture of these three places. Now, this is something that I had worked on in one of my research papers. In trying to find contextuality in vernacular. Now, the main reason, as I was also hinting at the beginning of my presentation, the main reason why vernacular architecture is being shunned by people or being ignored by people nowadays is that many of them don't find it contextual. They don't find it at par with their economic status. Even if they're low income, they are earning a lot and they don't feel really comfortable enough, prestige-wise, I think, in many cases, status-wise, to live in all these vernacular houses. So we need to find contextuality in vernacular, and for that I had made a basic matrix for one of my papers, and I am showing you excerpts of that. First thing is, of course, climate responsiveness. In order to evaluate any vernacular architecture of any place, be it India, be it abroad, we need to understand, first thing is how suited it is to climate. If it's not suited to climate, it's useless to have that vernacular architecture. We can try out other solutions. Number one. Number two is aesthetics. Of course, aesthetics matters, and a lot of vernacular architecture is studied just because it's so attractive. There are a whole lot of documentations done, a whole lot of books written out of the beauty of the earthly beauty of vernacular architecture. Third is building materials. Now, we somehow under the misconception of vernacular material is only mud and bamboo. It's of course not, as the previous presenter so nicely put it. Even timber is a big thing. Granite, even that's a vernacular. Anything that's available in your region, any type of stone, any type of locally available stone in your region is a vernacular stone, actually. And you can find places in Rajasthan and even in South where there are certain specific types of stones available in abundance. So if you're using that stone, you are contributing to the environment consciousness, you are contributing to the greenness of your building, and you are retaining the local character of that area. You should be proud, every region should be proud of their character, and architecture is what's going to stand. I mean, the Mughals have left, the Mughals, their kingdoms have been wiped out, but what stands today is their buildings, and we can learn from their buildings that yes, they lived in this way. That is what is the beauty of vernacular architecture, that their materials they use was this, the construction techniques they use was this. It's documented, it's so clear, and it's standing tall and strong. So that is why buildings remain to tell the story, and that is what I mean. If you, if say some nuclear war or something wipes out the world, and after 200 years to 500 years, someone starts digging up and finds all these abandoned buildings, it will be very difficult to tell for them that which building was which area and which building had what character, because it's almost become uniform. And influence on built form. Now, the influence on built form is, of course, a summation of all the previous three aspects, and how your courtyards are planned, because courtyard planning actually in a tropical country like India is very relevant. Now, the thing is, you have to actually place the courtyards properly, but somehow it's been ignored very widely now, because courtyards also have a very calming, soothing effect on the occupants inside. because we are nowadays talking about biophilic architecture and connect with nature. The easiest and most traditional way to connect with nature is actually having properly placed courtyards, which offer you shade, which offer you a bit of openness, which offer you a bit of light. And we have even mental problems are on the rise because of our closed living. Yes, we do not have any choice, but even in that aspect that we do not have any choice, we do have some choice. Architects, that is the new challenge in front of architects in vertical high-rise structures, how to create these spaces. Why even our great late Charles Correa, he interpreted the vernacular in his own way in the Kanchenjunga Towers with his wraparound verandas, and where he used stack effects so nicely. Arabian Sea breeze coming in from a lower placed opening and then going through the house and then exiting through a higher placed openings. There's stacking, those level changes, those wraparound verandas, those small bits of terrace green spaces. So all these, they are actually, that is one of the best examples I've come across of interpreting vernacular ethos in a modern day context. So that is where influence on built form, that is where our actual role comes into being. I mean, everybody will, the first 3 points, everybody will document. But when it comes to practically implementing it in the influence on built form, that's where somehow we, due to various reasons, we lose the plot to a certain extent. So continuing with the same, beginning with Bengal. So Bengal had this chalas type of architecture where you have this curved surface, and as the sketches below show also, there are the famous Bengal temples of Vishnupur, terracotta temples, and before that also, that was these temples date back to around 15th century. But before that also, the first Islamic invasions had started happening in India, and there also Bengal was also for a major part of that decade when other areas of India, Deccan and Hyderabad and other areas were under Muslim rule. Even Bengal was under the same. And then they had those in Murshidabad and areas in the north of Bengal, they had those curved roof thatch structures. I mean, not thatched, curved structures, which were not made of thatch, of course, but they were the Adina mosques. Some of you must be aware of Adina Mosque, Murshidabad and Hazrat Duari. So that's when the style started. And then they built these famous Vishnupur temples devoted to Lord Vishnu at Vishnupur. The name of the place was also Vishnupur in Bakura. And these were terracotta temples. Terracotta is nothing but local soil clay, burnt clay, and it's still standing strong after so many years. And it's a heritage site. Actually, it's a very important heritage site, and it's extensively documented. So these temples actually absorbed a bit of Islamic architecture, and that way the unique vernacular Chala style, Chala is C-H-A-L-A, Chala style of Bengal architecture started. Now, right after these Vishnupur temples got built, the East India Company officials started to arrive. And one of the first places they arrived was in Calcutta, of course, along with in Bombay and Madras and some other areas. Surat also, some of them arrived, but Calcutta was one of the first places they arrived. And they started getting influenced by this as well. So that's how evolution started. I'll tell you exactly how they started to get influenced by this architecture, intrinsic indigenous architecture, Chala style of Bengal. Now, this Chala style of architecture is there in the figures, and you can see that where my cursor right now is. That was the original Chala style of architecture. Now, when the British came and they had come from a hugely distant place, and when they came, at first they interpreted it in this way: canvas tents and all those they set up, and then that gradually got converted, and since it got converted not only by the British, the villagers, the rural people also started to use that, reinterpret the Chala architecture in their own way. Now, when these improvisations got happened or were happening rather, after the tents, they had, of course, the roof got evolved further, and then they started using something like louvers, which was the climate responsive feature, which is where my cursor is at right now, where they use jhaps. This is basically a shield against the hot summer sun of Bengal. Jhaps. They use, this is nothing but something like khaskhas, or in more modern day louvers, which we use. They use at that stage they use jhap because they were feeling the brunt of the hot tropical sun in Kolkata and nearby areas, and they used this jhap to cover the doors and windows. But at the same time, they had gaps, slits in that jhap, much like that we have in our louvers. And these jhaps allowed the ventilation to come in, because in a warm, humid area like Kolkata, you also need a lot of ventilation. So these bangla houses, they got improvised, and that was the origin of their bungalow, the British bungalows, which are famous even in Barakpur and some other areas. Barakpur is where the first war of revolt started, the 1857 revolt started. There's an extensive area where Governor General used to stay. The Governor General Canning, Lord Canning used to say, and there are all these bungalows. That was one of the first places where these bungalows, which were actually inspired by this Chala style of architecture, happened. And you know what, the British, they've been technically very good at that time actually. And what they did, they just extended, they improvised, they actually interpreted the vernacular architecture in their own way, taking the overall silhouette of the existing Bengal Chala style architecture. They actually projected out the roof and had a wraparound veranda, which protected the, now that they used to sit out in that balcony or veranda actually, which surrounded the entire building. And it was covered on top from the overhanging eave. And that was a place where they had their evening tea and they had their meetings and they enjoyed the nature in general. Most of them actually, even the place I was talking about, Barakpur, they started settling by the river Ganges. They had a unique fascination with Hooghly River or Ganges River. The Bengal stretch is known as Hooghly River. And they all started building their bungalows there. And they enjoyed the sights and sounds of India from there actually. So they interpreted in their own way, which was actually a climate responsive way. And that is why how actually British style bungalow architecture came into being. The origin was our, and it's actually documented. This is one of the papers I had written with another co-author, but there are other examples and there are extensive works done on the same actually. So that is how we can actually use and interpret vernacular architecture. So these were some of the transformations that happened, and these transformations started happening in the 1800s and later, and they developed into a distinctive roof shape. As the eaves grew more projected, forming veranda-like spaces, galleries began to develop on sides of the structure. The eaves descended lower at the corners, and this was very, very responsive to the climate of Kolkata and surrounding areas. I mean, lower Bengal, middle and lower Bengal, very, very responsive. Now, these chalas had a lot of variants, which is worth mentioning here. There were the art chala, which had 8 slopes. And this type of architecture is also found in the Santhali tribes in the border of Bengal and Jharkhand and Odisha. So they have these roofs with 8 slopes. And but this takes a bit of expense to construct, so you won't find it in the lower economic strata people. The people who are a bit well off, they are the zamindar's house or the village panchayat's leader's house. They have these 8 chalas. It's become a status symbol. Then you have the char chalas also. Char chalas are, char means 4 in Bengali. In English, if you translate char into English, it's 4. So they could also fit in more than 1 rooms, and in the more advanced profiles, they have courtyards in the center. And then the do chala, which is the simplest one, which is the one which I showed here. I'll just go back. Do chala one. The simplest one is the do chala one. This one, which is actually this is also a Charchala one. The Dochala one doesn't have these two also. So this is a Charchala one actually, and this is the Atchala one. Okay, the simplest one is the Dochala one, where there are just two slopes. So that's each of these is a chala actually. Even in the Atchala ones, I've seen a lot of varieties where they have actually introduced stack effect because they have the second part, the upper part, they have lifted it above this part and created, I mean, clerestory window sort of things for lighting, and the number of good houses also in Bengal which are existing, which have used this, and they have those top hung windows which can be opened when the weather is good, and they can allow some cross ventilation and stack effect like things. So it's all become part of the architectural heritage, and tragically much of it is not recorded that way. That's the difference between what happens in European countries and other advanced countries, American countries maybe, where they are very good at documentation. Our documentation is there, but it's haphazard and it's very scattered and it's not very properly done. So now we will come to materials. Now materials in Bengal, unfortunately, I'll tell you, I somehow missed a slide about materials of Bengal. And from now we are actually beginning on Kerala. So the materials of Kerala are there. Yeah, with respect to, I'll just briefly tell you about the materials that Bengali they used. Of course, one of them was terracotta that was extensively used. And then in the architecture, Islamic architecture at Pandua and Gaur, Hazardwari, they used lime. Lime was extensively used, as was much of, as it was a favorite material, as you are all aware of, lime and lime plaster and surkhi and lime. That was used as usual because it was the same gharana of architecture actually. It was the Deccan Sultanate architecture only, and it was the Islamic architecture only. It was the Bengal Sultanate, same kind of architecture. And they used a lot of lime plaster. They used these clay and burnt clay bricks and terracotta, as they say. And there was, in some isolated areas, some stone was used, but not much of stone has been used. And of course, in rural areas, rural Bengal is famous for thatch. Of course, thatch is an outdated material, though even in places like Germany, and if you have been through the book, Earth by Gernot Minke, you'll notice how effectively thatch is being processed. Low-cost thatch, which is totally safe, which is fire resistant, is processed and used in Germany, places. And thatch matter is a very good insulator, so they are actually finding it very easy to use even in cold areas. They are using a thick thatch, and they are utilizing it very, very well actually there. So all these things are actually been very useful. So now we move on to Kerala. Again, a different story. I selected the states in such a way that they offer different perspectives. Now, Kerala was influenced by British. Of course, every part of India was, but the influence of British architecture was somehow more in Kolkata and Mumbai and Chennai, the major metropolis. Kerala had its own romantic architecture developing, and of course, as many of you would be aware of, it's about mud, basically laterite, red brick, granite stone blocks, lime mortar. Of course, lime mortar was commonly used all over India. Wood. So it's a much more versatile and much more combination, varied combination of materials: bamboo, clay roofing tiles, and coconut palm leaves, or palmyra leaves, as they are called. So now, timber was mostly used as a structural element in Kerala architecture. So they, in terms of indigenous technology, Kerala architecture is one of the most advanced in India actually, and a lot of architects, including Professor Architect Harimohan Pillai, has actually documented the extensive types of construction techniques, indigenous construction techniques depicted or used in Kerala in something as was particular as roof construction technology. In that only there are a varied number of local indigenous technologies that have been used through the years in Kerala architecture, and something that can be actually used in modern architecture. Now, the thing about laterite is many people think it's very hard and something, but that's how important exploring your local resources is. There is soft laterite available at shallow depth in Kerala, and it's a rare local stone actually. You won't find it even if you go to faraway places. You won't find it if you come to, say, Madhya Pradesh and search for that. You'll get that right next to you in Kerala only. That's how important thinking local and rather acting local and thinking global is. So you have to act local. You'll find the best materials more often than not, as was found in Kerala, at your nearest doorstep. So there is a local stone that gets more stronger and durable with exposure to the atmosphere, and that's why a lot of their buildings are actually made of this soft laterite, which has this unique property. And then they use a lot of shell lime because it's a coastal area. So, and shell lime is actually a classic binding material for traditional buildings. And they also use this inferior variety of laterite stone, which is locally known as chical. So this is what is local marriage, an ideal marriage of indigenous technology and indigenous materials. And nowhere is it best exemplified than it is in Kerala. So I've taken from Dr. Harimohan Pillai, Professor Dr. Harimohan Pillai's works. You can easily go to his website and see in more detail. See how meticulously he has identified these roofing typologies. See, and how he has also shown how these are used in, as my cursor is moving, how they're using things like stack effect, where you get adequate ventilation, where the hot air rises up and escapes, how they have all these complex, intricate structures, which can be easily replicated in other materials also. I mean, it can be done if you if you'd like to do it, you can do it in any other material. Even bamboo is a very viable material used in a lot of modern conditions also, because if you treat it for waterproofing, which can be done by some treatments like borax treatment and make it insect proof and waterproof, then it can be, and you can also integrate it with reinforcements, then it is one of the best materials today also. So hollow bamboo or whatever. So all these things, these are work which is actually being done in with regards to the skillful use of timber and how you carve your woodwork. If you care for the aesthetics part, how your, because that's how architectural character is gained, by some uniqueness in your architecture, by some unique carving of woodwork in your architecture, some joinery details, some framework, something which actually lends that exclusive touch to your indigenous architecture. That is what vernacular is all about. Vernacular is equally about indigenous technology as it is about indigenous materials. It is not about indigenous technology. Surprisingly, Griha ratings, IGBC ratings do not have any points for indigenous technology. They have innovation, under which a wide variety of gamut of points come in, but they don't have, they have for locally sourced materials, but they don't have individual points for indigenous technology. At least Griha should have. So that is where we are. That is where we have to learn from vernacular techniques actually. And climate responsive, it's very high. Climate responsiveness in Kerala architecture. Professor Dili and Nasir and others have done extensive work, and many others from NIT Calicut have done extensive work on how well Kerala architecture exemplifies stack effect, and how you see the overhanging eaves is so comfortable. I mean, the look of the house tells you that even on the hottest day, it will be comfortable. See how nicely they're using the courtyard to make the hot air rise up and leave, and how bringing fresh air from outside. So it's amazing. And they use shingle roofs, by the way, basically based on Mangalore tile shingle roofs, where all the tiles are interlocking into each other in a unique way. So those shingle roof use and protruding eaves are a very good response to the tropical rain, and of course for the harsh sunlight, harsh rays of the sun. They cut out the glare by having a porous walls, the I-shaped building mass is very good for a warm, humid region because it offers you a lot of things. It offers you mutual shading. It offers you cross ventilation. It offers you ventilation on alternate walls. And they have an open plan, which is, of course, a bit desirable in warm, humid climate. We go for the closed, inward-looking plants in hot, dry areas or cold areas. But in warm areas, to let the wind in, we need a bit of open plan, but not too much open so that it exposes us to too much heat, of course. So these are pointers. These are things we need to learn from vernacular architecture. Regarding socio-cultural influence, nowhere is best shown in vernacular architecture. As I told you in case of Bengal also, the socio-cultural influence is shown by the gradual transition. See, eras of Bengal history are actually documented in their buildings. First, we have the Mughal architecture styles, and in which the Chala style first evolved. Because if you see the Hazardwari and Murshidabad, all those remains of Mughal architecture, you will see the first semblance of Chala, that curved roof. Then if you go down to Vishnupur, the burnt clay architecture, you will see further development of the Chala style. Then, as I told you, the British came, and the British, because the Vishnupur style actually came as there was a Bhakti movement, there was a revival in between the Islam period and the British period. There was a revival which was led by a lot of saints all across India, in which one Bengal saint was also taking an active role. So it was a culmination of the Bhakti movement in which that period came. Then, and of course, there were the kings, the Ballal saints, the kings of Bengal also at that time, who were lending their bit to that built heritage. And then with the coming of the British, the socio-cultural influence is nowhere better seen than in the transition of vernacular architecture. But the British, to their credit, converted it into a more technologically feasible solution, which was responsive to the climate, which offered them comfort, and which also looked good. There are a lot of British bungalows which are actually heritage bungalows and maintained here because they deserve to be maintained. So in that way, the environment is reflecting the socio-cultural forces, including the religious, family and clan structure. For example, social organization and family structure are very well represented in Kerala architecture, as many of you would be aware of also. And it was documented by Amos Rappaport that vernacular dwellings are more a result of the aims and desires of an unified group for an ideal environment. Maybe that's why we are not recognizing the importance of vernacular architecture in the present day. You know, people used to be more united before, because we can't stand if we are not united. So there, 100 years back, maybe it was our buildings, our societies were a reflection of the common aims and desires of an unified group. But today, man has become so individualistic. Maybe that's why we are sitting in our 25th floor high-rise apartment, and we even don't know whether our neighbor is dead or alive, and neither our dead neighbor know whether we are dead or alive. So it's a reflection of times, maybe, but still we have to maybe unlearn some things we have learned, and learn some we have forgotten, relearn some things we have forgotten. So, for example, you will see how nicely the socio-cultural influence gets reflected in Kerala. In the district of Kottayam in Kerala, there is a traditional strip of canal settlement with a couple of rows of traditional vernacular housing facing the river, and the boulevard flanking both sides of the river. Now, these strips actually belong to traders and merchants who were Muslims and Christian Syrians. So that's how that entire space organization came as a result of those traders and merchants who were not typically the original inhabitants of that area, and gradually over time settled in that area. And of course, that got reflected in the housing typology. So that is where, in that time, that is where an eclectic vocabulary of Kerala, Southeast Asian and Portuguese styles exist. The seashore settlements around, and especially around the areas which used to be once upon a time ancient trading ports, they show eclectic features which borrow a bit from Portuguese styles, which borrow a bit from some of the Malaya styles, and of course, which got blended with the nature of Kerala. Now, why in this globalization, age of globalization, can't this be a baseline for our designs? They are actually, there are people who are using this, who are referring to this. There are people. For example, one of the person who is very much into this, and I follow him, is Benny Kurkiaos. He was a civil engineer turned architect, and he's been doing some exceptional work. So there are people who are actually doing like this. So that's how important sociocultural influence is on a vernacular settlement, on the way vernacular architecture progresses. So again, coming to indigenous Kerala vernacular, you will find Agraharams. Now, Agraharams are, of course, they belong to the typical style of original inhabitants of Kerala, the Brahmin communities. And they had their typical rule of having 2 rows of housing running north-south of the road. One end has to be a temple of Shiva and the Lord Shiva, and another temple of the Lord Vishnu, and they follow the traditional style. But it's again an example of how vernacular architecture actually evolved in response to culture, in response to the socio-cultural beliefs, of which religious beliefs are also a part of. So in today's context, our definition of culture, socioculture, has changed. Of course, we are not like our ancestors were 50, 100 years ago. But today's our architects, our urban planners can think of settlements which are or existing settlements. They can think of remodifying based on plazas and where needs, and have all those integrated town development, which has not happened. And of course, in most cases has not happened. And still there are new developments which is yet going to happen in India because of our burgeoning population and increasing population. We need it, and maybe we can take care of those things in later times. Now, moving on to another part, very different part than Bengal and Kerala, Gujarat. Okay, so Bhungas. Now these Bhungas have their own traditional style. They follow that strict fixed rule of hot dry area architecture. That is that you have to have your building shapes as compact as possible. And if being a desert area and they being economically limited, they have very less access to materials. So they have used wattle and daub and mud, sun-dried clay blocks. And then they evolved their own unique traditional, as you can see where my cursor is, unique traditional method of construction, and they are getting very good results out of it. Actually, Bhungas have been extensively documented, and they are found to be very, very comfortable. See the layout, compact layout, which doesn't allow the closed inward looking layout with a small open space in between, which does not allow your hot desert winds to come inside. So adaptive to the climate, so adaptive to community living also. In those harsh conditions, they have to depend on each other. They can sit together in the afternoon, after the women folk can sit together in the afternoon after their work is done and discuss about the day, discuss about life and its challenges and all. This is it's a unique piece of architecture again, and they have their own particular type of construction methodology, which is actually particularly of roof construction. So Kerala had its own style, Bhungas have its own style. So, and conical roofs actually help a lot in hot dry areas, because the difference between a conical roof and a flat roof in climate responsive terms is that in a conical roof, all parts of your roof are not getting heated up at the same time. Whereas in a flat roof, all part of your roof is getting heated up and it takes equally larger time to cool down. But in a Bhunga, when the sun is in one particular direction, one particular part of your conical roof is getting heated up. The other part is not getting heated up. So by the time the sun moves to the other side and heats up the other side cools down. So even in that way, it has an advantage actually. So I had actually done a research on this and I had compared these things with, I've just produced a snapshot of the same about each of these parameters of the indigenous Bhungas with respect to our modern day green building standards, with respect to site planning, with respect to energy performance, with respect to material use, recycling, and with respect to environmental quality. And it was really found out that most of the parameters, these Bhungas were performing very, very well. Because, for example, with respect to site planning, we are preserving and protecting the landscape during construction. We are reducing site disturbance. All the parameters on which IGBC awards points, or all the parameters on which Griha awards points, we are taking care of them. So we are preserving the natural ecology. We are preserving. We are making reducing the entry of the hot winds. We have energy performance wise, of course, it's an optimized design, as you can well understand. It's a very compact spherical shape. We are exposing least amount of exposed surface area to and allowing maximum volume inside. So, and also it's a very earthquake resistant as well, actually. So that's in a way, in an earthquake prone area, it's an advantage, actually. The cylindrical volume is good in a way. And of course, the material itself is good in case of a natural disaster like an earthquake. Of course, with regards to low embodied energy, mud is the lowest possible embodied energy material that you are using, and you are sun drying it. So there's no question of any industrial process coming into being. You're using wattle and dwarf. You're using some local available grass types there. Grass is used as an insulator, thatch or grass. Actually, grass is used, dried grass there, which is typical to that area. That thatch is different. Our thatch in Bengal, Bihar, Jharkhand, even Andhra, Orissa, that thatch is different from the dried grass that they use, a little bit different, actually. So then these beams and rafters, they are using of local woods. They have their own typical desert type woods which is available and which I have listed here. Kerad is one of them. Gando Vaval is one of them. Limestone is something that is available, and they use it for foundation and plinth, actually, of those Bhungas. So it's not all mud. So they are using appropriately limestone in foundations and plinth structures. So this is the way. So in Kerala, we saw some soft laterite, some special type of laterite which is available. Here it's limestone. So in Bengal, it's terracotta, burnt clay. So each of our areas, India is very rich in materials. And of course, indoor environmental quality, they are maintaining it as far as possible, because they are cutting out the hot summer loo, they are cutting out the cold winter winds. They are, in all those ways, they are maintaining the indoor environment quality as far as possible. Now, Hassan Fatih, now looking at a global level, Hassan Fatih, of course, New Gourna village, Egypt, he must be a well-known name for most of us. He also worked a lot on revitalizing vernacular architecture of New Gourna village. Gourna is spelled Gourna. So for about 3,000 families, and it's a globally held example. He won the Aga Khan Award for the same, actually, also. So he created opportunities for passive cooling, which in those vernacular mud dwellings, basically. Stack effect, as you can very well see in this drawing, and so aesthetically beautiful as well. Simple, how made simple buildings into something much more. So you had a lot of cross ventilation and everything. And actually these models can be replicated in other buildings also. So that is where vernacular architecture becomes so important. And if we treat it well, and if we take the right steps to make things work. So now we come to our lessons. What are the lessons we have learned from our tradition, to which we can take forward? Now, of course, we know that traditional way of living was inherently energy conscious, and it has strong linkages to the environmental and climatic context, no doubt about that. Now, many of the traditional features are replicated in some modern buildings, but the functional utility of the buildings are somewhere lost when we are trying to do it. Some cases it has happened. That's where judiciousness comes into being. And also, what we need to do for the future is one area. Now, research has to be the backbone of this. We can't just start building. I mean, novices can't start just they soon pass out 2 years down the line. You can't expect them to start incorporating vernacularity. I feel that this needs to be supported by some research. I mean, many people say in architecture research is redundant. No, it is redundant if done in the wrong direction, but if it's done in the correct direction, I feel it's definitely as important as it is in other engineering branches and other technical branches and other science branches, because architecture is also a science, and more so what we are talking about, climate change, adaptive architecture, is building science. So we have to have some research. And I feel that our traditional materials and techniques can be analyzed in terms of energy consumption in future studies. This is one area of research that I feel is very essential. I also feel that vernacular strategies that have been existing in India, we are not studying them in that detail. Not much quantitative studies have been done in that field. And I feel our future, since there is now this rush for PhDs for teaching posts, including architecture, something that was not there maybe for 5-7 years back. Now we need to take it seriously and maybe turn this into a right direction. Maybe our research can be guided. Maybe our supervisors can guide their these lines. Again, appropriate planning devices like courtyards, orientation, etc., should be employed more stringently and more properly, and stress on locally available materials without major modification in their organic state should be encouraged, along with the use of local crafts and skills. Somewhere we are also losing our local craft and skill base. Now, reinterpreting some examples that I've taken from some of the work of Professor Harimon Pillai also, and some other works also, in which how we can reinterpret. This is one example of a Kerala modern day house reinterpreted using the vernacular traditions. This is again, see the traditional timber roof on where my cursor is right now, and see this is the modern interpretation. Nicely done, as nicely as possible done, and looks very good also. So it can be done actually. Nothing says it can't be done. It's simply that most cases we are guilty of not simply doing it because of many constraints maybe, but we have to overcome some of those constraints at least. Again, this is something that was suggested by climateconsultant.com, where typical construction, lightweight construction in warm humid areas, this can be even modularly done for that matter. It can be even done by recycled matter. That's how we reinterpret vernacularism. Vernacularism nowadays, we have so many things. We can recycle baggage, we can recycle paper, we can make materials out of nothing. Out of waste, we are making materials, waste to resource. So even those materials can be modularly prefabricated in the industry and put together. For example, this type of a building can be so much prefabricated as a temporary dwelling, as a whatever. So the prefabrication can also be brought into this entire picture. So it's not that we go back 50 years back into some archaic technology. It's that we learn the lessons and reinterpret in a new way, in a better way. Now, these are some other indigenous vernacular techniques worldwide. You'll be surprised to know that there are other techniques also which are there, like this one, rammed earth domes used, and which were actually the basic plan. This one, in which it was the upper one is a Nubian dome. That's the and the Persian dome and the Nubian dome, which was used in Middle East basically. What I'm talking about, the rammed earth dome with buttresses, is this one, where the basic outline is a hexagon, and see the load transfer is done so nicely using buttresses. So these are indigenous techniques used in different parts of the world. And again, in Egypt and Persia, you have these type of dwellings with wind catchers, and these are thousands of years old actually. So these have been used, and these are existing uniquely. So this is a unique construction technology again of of construction of Nubian domes, which are still being used. If you happen to go through Gernot Minke's Building with Earth, you will get examples of some of these vernacular architecture practice. I can tell you that some countries are very much into earth architecture and other vernacular architectures. They being Germany, Mexico, Spain, parts of USA, Texas, they are doing it, and it's not that only economically weaker sections are living in it. People are living in it out of their own choice. They are going back to the nature, and they're enjoying it. So maybe we need to slow down also and readapt to these techniques again. And of course, these are Auroville has very good presses, Tara, Balram press, and all those presses where you can have specially designed compact soil blocks, which are a mixture of clay, sand, and fine gravel, and under controlled conditions. So where we keep the pressure usually in between 60 to 100 kg per centimeter square. We have small steel molds, and these are actually known as green blocks, actually soil blocks, green bricks. Very, very eco-sensitive, environmentally friendly, and something that is very much in line with adaptive architecture in view of our climate change. It releases leaves a very less carbon footprint, and it can help us a lot. And you can stabilize it with the addition of a little bit of lime, and it works more. It is much more water resistant, and in areas where it doesn't rain that much, you can use it very easily. And even there are ways in which you can actually counter the water threat. Though in these type of blocks, the water threat is itself countered to a large extent, there are many other ways in which you can counter it even more. And these are actually controlled, these are prepared under controlled conditions. So we are using technology in the best possible way. Only thing is that we are not getting into it. Now, how do we actually get just talking won't help? So maybe there are some things which we can do to outline or to further elaborate the points I discussed in the last slide. One of them is, of course, to recreate the thermal properties of traditional materials with modern day industrially produced materials, or maybe materials produced from waste also. We can try that. That's a huge area. We can also have to calculate properly the thermal conductivity, transmittance, and insulation properties in greater detail of bamboo reinforced rammed earth walls and actually document it. We need to do a comprehensive study of thermal properties of non-stabilized compressed earth blocks and have it published in ASHRAE, which is the American Society of Heating, Refrigeration, and Air Conditioning Engineers. So the thermal properties have to be documented. Right now, it's not documented officially, actually. Some researcher does some work, he publishes it, we cite it. If it's in a good journal, that citation is accepted also. If it's not, in many cases it's ignored. So that's not the way. We have to bring out something like BIS, Bureau of Indian Standards, has, in fact, many people are also not aware of it. We have a code on the construction of rammed cement earth wall, soil walls for rural houses way back in 1980. Now, further codes need to be brought in. Since 1918, no other code has been brought in. Now, that's not the way. And also, we have to explore more on rationalized traditional technologies being used and researched upon. As you are well aware, in your own city of Hyderabad, you have the Rural Building Center of National Institute, NIRD, HARTCO initiative. And but we have to take it further. I mean, we have to take it into other climatic regions, because just having 16 prototypes may not work for present day India, because so many microclimates have developed, and we have to develop for each region, and more research grants have to be given for this, rather than doing some continuous studies on thermal comfort. Won't help, in my own opinion. I mean, thermal comfort, we all know, if you are comfortable, you are comfortable. And how can you be made comfortable? By appropriate building, by appropriate design, by appropriate materials, by appropriate passive design interventions. Just measuring 1 degree here and there of thermal comfort don't really take us anywhere. So maybe we need to marry research in architecture with practicality in architecture, and take the way forward and learn our lessons from vernacular architecture. So for now, that is it. And I'm glad to be given a chance to present. You are welcome to ask any questions if you feel the need. So, yeah.
Good afternoon, Professor. It was a very nice presentation with this, so much of effort in understanding the various vernacular architectures of India. Definitely, the effort that went into the presentation will give everyone more energy to look the vernacular architecture of their places in detail so that they can understand better the vernacular architecture. Thank you for the presentation.
Yes, yes, thank you, yeah.
Sir, there was
So you
one
can share
question
my
from one of the
presentation with
participants.
all. Yeah, you can
Yeah,
share the
so there was
presentation.
one
I have
other
no
question.
issue. Okay.
Oh, okay, okay. That's great, sir. We'll definitely share the presentation with the participants. So one question is, what are the possible tools that an architect can use to build a bridge between vernacular, local and global materials, which can make a building resilient?
Yeah. The first tool, there are a couple of tools, and the one of the first tools is a proper research. I mean, research has to be a part of it. I mean, first you have to study the existing vernacular types and then understand how they have been implemented, how they have been operated, and then try to conceive how they can be reinterpreted in a modern way, how that same construction can be carried out in the modern day scenario. That is the research part. The second part is software modeling is important for this, because you can't be very sure of whether your vernacular technique is going to work and whether your reinterpreted vernacular technique is going to work, because many cases you won't be able to use the original material given the present day context. So you have to maybe use some other material to recreate that similar sort of thing. So for that, I mean, if you're making that actual material and then testing it in the lab for its thermal properties or for its resilience to climate and resilience to environment don't help. So what you have to actually do is you have to simulate. So in this case, climate simulation tools like Design Builder and other things will NVMet also on a larger scale will be helpful. So research, software tools, and thirdly, you need to look into the product design and industrial design part of these things, because as I also had mentioned, some of the items need to be recreated, because the way they were used 500 years back, even 200 years back, you can't use it in the same way. So you have to find out viable alternatives using waste and low cost materials, and where possible vernacular materials, to create similar situations which are adaptable to modern day and which are easily reproducible. So you have to have lab setup, more lab setups for and researchers working on these replication of these materials. So, and of course, if they have to be incorporated into codes, as I have mentioned here also, the vernacular techniques are grossly neglected in the codes, in standard codes. So that is what I feel. Could I answer the person's question, or was he or she asking something different? I mean, the moderator can just clarify.
That's a good answer, sir. So if they have any further questions, they can ask. So any other further questions? Okay, she said it's very helpful.
Okay, yeah, thank you.
So do we have any other questions for Dr. Gupta?
Also, if someone wants to make a statement about the whole presentation, yeah, they can unmute and please. So Hemam, then we can break for lunch and
Sir, sorry. I'm
Yeah.
Dr. Naveen Kishore here. Sorry.
Yeah.
Okay.
Yeah, I just would like to ask one question to sir.
Hmm.
Yeah.
Sir, this was a very good presentation, sir. Thank you, sir.
Yeah. Thank you.
The thing is, I want to ask one question. That is, see, presently the codes which we are having, like for example, SP41, right, the Handbook of Functional Requirements of Buildings.
Yes.
In that, we have the prescriptions for all the the conventional materials, right? The
Yes.
thermal conductivity and all that. So, like you said, we have to do research on these. What is that? Waste materials and this, like
Yeah, and
for
the
example.
mud-based materials, wattle, bamboo-based material, all those vernacular materials, so-called. Yeah.
Yeah. So actually, the code actually, if you see, it was updated last in 1987, as far as I remember.
Yes.
But after that, it has not been updated. So,
Yeah.
so probably like what you said was like we should do the research on these materials and then include that in the code, and then that would be a very good, way of
Absolutely, sir. That is what I feel the major roadblock. That is why if you tell me, sir, you hit it right on the A. If you tell me which is the major obstacle, this is it. Because you see, we are working with outdated things. We haven't done anything after that, and just presenting some things won't help. We have to formalize the system. I agree fully. So, that is true, actually. Yeah.
That's true, sir.
So.
Yeah, that's what.
Yeah,
That's what
actually,
Unfortunate that, as you pointed out, last time it was updated was somewhere around that time, 1987. So it's very unfortunate that this is the situation.
yeah, actually,
Yeah,
like
actually,
there is not much discussed upon about these vernacular technologies and vernacular knowledge, and most of the time, many people feel that they are not suitable or they are not
Yeah.
of good quality. But every technique and every solution is a solution for something very particular. So we should be able to drive that point and
Advanced the advanced countries are not thinking like this. I mean, as I
yes,
told
yes,
you,
yes.
Germany and some other countries, they
Yeah.
have, in Kassel University, in a university, highly acknowledged university in Germany, they have an exclusive center where the researchers are working on mud-based architecture in a
Okay.
country like Germany.
Hmm.
So I think we are losing something here by ignoring this aspect of our, and we are more richer actually in vernacular terms, not just mud. As I told you, we have so many materials. We have laterite, we have variants of laterite, some laterite which can be worked upon so easily, and so we are ignoring. And it's high time we actually do it. But yeah.
sir, hello, sorry to disturb again. Can
No,
I
no.
ask another question, if you
Yeah,
don't
yeah.
Yeah,
mind?
please, sir.
Yeah, sir. The thing is, see, we have a lot of rating systems in our country. Like Griha is there,
Yeah.
IGBC is there, and
Yeah.
ECBC is also there for energy
Yes.
conservation, right?
Yeah.
So,
ECBC is the mandatory one actually. Yeah.
yeah, but
We have
these
to.
are also actually using the conventional materials only. If you
Yeah,
see in
that
the ECBC,
exactly. That's what I also pointed out in my. I just told it. Even these days, they don't even have a section on indigenous materials. Actually, they are talking about local materials, but they are not talking about indigenous materials, indigenous construction techniques. If you are using it, you get some points, or if you are using it in a reinterpreted way, you get some points. So it's not there. They're silent on it. At least Griha should have. Maybe we can excuse Sir IGBC for not having it, because their whole origin was commercial in nature. They were there only for air conditioned buildings, to give them to move to help those big corporates do away with the stigma of using air conditioners all through the day. But at least for Griha can have a special section on local indigenous buildings, where they can, at least to promote other buildings, they can offer some incentives, financial and ratings, and popularize the buildings by having these sort of incorporating these sort of. I don't know why it's not been done. Because IGBC you can't expect, sir, as many of you are well aware, sir. They are absolutely actually they are a sort of business only for. I mean, I shouldn't be saying this, of course, but at least Griha should have it. So because it's all for formalizing air condition and buildings, hospitals and convention centers and offices. Yeah. So.
Yeah, that's what, sir. That's thank you.
There's another question. If is there any green rating system that is available for vernacular buildings?
No.
No, not really, actually, ma'am. Griha and IGBC, the major two green rating systems. ECBC, of course, is a mandatory. Most of the states it's been made mandatory, and soon it will be made mandatory. It's not really a green building code. So the existing codes mainly followed in India, it does not have, ma'am. It has only to the extent that it gives you points if you are using locally sourced materials, and it has also got some points for special innovation techniques used, in which some of these points, if you are using, can come in. But clearly, it does not have any particular points as to if you are using some local indigenous vernacular techniques or local indigenous vernacular materials. For that, first, what are the local indigenous vernacular techniques has to be defined. That only is not defined. So maybe that is one of the reasons why they don't have this point to avoid controversy. But at present, they do not have it. No, you can't say that they have it, because they are only given points for locally sourced materials within a 400 radius. And 400 kilometers is also a huge area, ma'am. I mean, 400 kilometers is a huge area. So, yeah.
Okay.
At present, they don't have.
I think that is all the questions. Can all the participants please turn on their videos so that we can have a group photograph with Professor Gupta?
I'll stop sharing. Okay.
Yes.
I'll
Thank
stop
you,
sharing my
sir.
presentation.
Hello, sir. How are you, sir? This is Venu Pandian.
Yeah, I'm fine, sir. How are you?
कैसे हो जी? It was a very nice and very interesting presentation. I'm sorry, I was having a little bit of trouble in my audio. It was a very interesting presentation, although, and you tried to cover almost most of the areas, which is like the shadowed part of the very valuable architecture. One has to put forth in the because things are changing, right? So as you said, this has to be
of course.
If there are some means that we can put forth in the standards, it will be very, very useful. But anyhow, thanks so much, sir.
That is the need.
Thank you so much, sir. I don't know too much of your time. Thanks, sir. It's nice.
Thank you, sir. Yeah.
Thank you, all the participants. I took the pictures.
Okay, thank you. So I'll join back at 2 o'clock, correct?
Yes, sir. Thank you very much for this session. Very informative session, sir. Like you said, we need to do a lot of research. There's a long way to go, a lot to learn from a vernacular architecture, and like you were saying, on-site implementation has to be done too. Thank you so much, sir. We can meet by 2 o'clock. All the participants, please log in 5 minutes before the session. Okay, please be back by 1:55. And we'll have the next session on climate responsive architecture, again by Dr. Janmajay Gupta, sir.
Okay.
Thank you, Professor.
Yeah. Thank you, sir.
The same link will be applicable, right? We have to log in through the same link for the afternoon session.
I hope all of you filled in the attendance. Please fill the attendance before leaving.
Hello, madam. There were 2 forms or only one attendance form we have to fill?
Same attendance form, sir, but this time you will select the this session, second session, instead of
the first one. I could not fill it. Actually, I could not get the link.
Okay. You can fill it now, sir. Yes, there was a small problem with that earlier. Now it's fixed, so you can fill it for both.
Okay, I have filled for the second session. The first session I have not filled.
First session also you can fill using the same form, but this time select the first one. Yes.
Okay.
Ma'am, I couldn't get the link for the form.
Okay, I'm pasting it again in the chat.
Yeah.
So I pasted it in the chat again.
Yeah, please. Thank you, ma'am.
I will also send it in the WhatsApp group if you are part of it.
Ma'am, since this particular mail, I just need to resend it to my Gmail ID. I'll just do it because my institute's Outlook ID doesn't allow me to access my WhatsApp. I'll just do it.
All right.
Yes, ma'am, can you please send it again since I've just joined the group?
Chat?
Can you please send the link again since I've just joined the group, so I don't have an access to the earlier messages.
Okay, you joined the WhatsApp group you're saying, right?
Yeah.
Okay.
Yeah, here, please. Thank you very much, ma'am.
Thank you.
And for the earlier session as well, ma'am?
Same one.
Okay.
Same form, you should be selecting this session. I've also included, yeah.
Okay, thank you. Bhai, I have a 2 minute.
Okay, I hope all of you have filled in the attendance. I'm going to close this session. And I'll be restarting the session just before afternoon. 2 o'clock, just before 2 o'clock, maybe 10 minutes before 2 o'clock, I'll be restarting this.
Yeah, the same link has to be used, no?
Yes, same link.
Yeah.
Same links.